Hi, everybody. This is the third lecture for the course. It's about measures of central tendency. And just like pretty much everything in statistics, they try to use very complicated terms for very simple things. So, measures of central tendency sounds very complicated, but you know one already ever since probably elementary school, and that is an average. So if I ask you, how do you get an average? I'm sure all of you would know that. You would take all the numbers for all the people, whatever those numbers are, like average height. You can get to all the people's height. You add it together. You divide it by the number of people. That's the average height for that group. And so you know that already. That's a measure of central tendency. It's an average, but we call it something different in statistics because, again, why would we make things simple when we can make things really complicated and confuse people? I'm not in charge of that. If I was in charge of that, I would change everything about how stats are talked about and taught. And so central tendency, I'm just going to say, sort of why they use that term. I want to make sure I can write here. And so it doesn't really matter what it looks like. So we could have a roughly normal curve. And central tendency is just saying, well, where if I was going to describe, so central tendency is another descriptive statistic. So just like the frequencies were descriptive statistics, it describes a sample. So does measures of central tendency, including things like average. So central tendency just basically so, well, if I'm going to give you one number, what number would summarize where basically most of the data lie? And so if we look at that, most of the data are lying around this area. And so here actually we probably would use a mean or an average. It's called mean in statistics. And even if we had a skewed distribution, even if it looks a little bit weird like this, we would still kind of ask, well, where's the center of the data? So we might say the center of that is somewhere here. But again, in statistics, we would have some sort of specific number we would give. But basically, central tendency is just trying to say, well, where do most of the people are kind of lying? If we kind of look where most of the people are, that would be a measure of central tendency. And so in this lecture, we're going to go over three major measures of central tendency, but they're all pretty easy, actually, and they're all pretty easy to calculate. There's actually just a couple that you have to calculate. One is you just look for it. So here's the outcomes. You can freeze this frame if you want to look at this. Otherwise, I'm just going to proceed. And so central tendency, again, in statistics, we like to have specific numbers for things. So I just drew areas where most of the data, most of the people's scores seem to lie. But of course, in statistics, we would give specific numbers. And actually, we have specific numbers for each of the three measures of central tendency. So basically, a way to define it in statistics is it's a single score that defines the center of the distribution, so where most of the scores are. I don't know if I'd say center per se. That's a little bit fuzzy, but where most of the scores are, I think, is more specific. And again, this is a descriptive statistic, so when we give numbers about central tendency, we're just telling somebody who's looking at our research, well, where are most of the people on the measure I had? So if I'm measuring height, on average or in general, where are most of the people? And so in descriptive statistics, we're just summarizing things. And so we have a number, and one number that we give is this number for central tendency, and it's a way to summarize what the distribution looks like, what the sample's data looks like. And so let's look at this. And so actually I might snip this. Yeah, I'm going to snip this so I can draw on it. Sorry about that. Let's snip it. So I can draw on these things, make it a little bit bigger. And so if I were to ask you for upper left hand right here, if you can see my cursor, where do you think the center of the data lie? Where are most of the people in this distribution? And this is a frequency distribution, so right there it says F, that's a frequency distribution, so the higher the box, the more people there are for that number. So the numbers here are whatever we were measuring, 1 through 9, but it looks like that people just have scores from 2 to 8. There's no box for 1 or 9, so there's no people that had that score. So for that distribution right here in the upper left, what number do you think best represents the center of the data where most people are lying? Well, it looks like a perfect normal curve in many ways, and so I hope that you said 5. Literally, there's more people at 5, and it's a normal curve, so we don't have to worry about skews or anything like that. So probably there is a good measure. How about for the upper right hand right here? What score do you think best represents the center of the data or where most people are? Well, on this one we have a negative skew. If I was to draw this, we'd see it's a negative skew here. So while it might be tempting to say 8, and 8 is actually one measure of central tendency. 8 would be what we call mode. It's the most frequent one. But then we know the average is probably down here a little bit, maybe around 5 or 6. But I'm guessing maybe somewhere around here might be a good thing. Maybe around there. Because the problem with saying 8 is that there's only 2 people that have above 8. So just because there's only 2 people above 8, that doesn't seem like the center of the data to me, and it's not necessarily most. And there's not much of a difference here. It looks like there might be a difference of 1 person here, perhaps. And so because it's negatively skewed, we might want to measure a central tendency that's down over here a little bit, just a little bit away from 8, because I think 8 doesn't seem like the center of data to me. How about the lower right-hand corner? Well, the lower right-hand corner, and hopefully you've answered this for yourself, it's a little bit weird. We don't have a usual curve. So this one, if we drew the curve as like a normal curve, if we drew this one, it's a skewed curve that's negatively skewed. So these are curves like we're used to, but in this case, if we were to draw this, I'll draw it over here. It looks like that, and then there's actually no scores in between those two, and then we have like that. So we have 2 bumps. So in this case, probably we want to acknowledge that there's 2 bumps. There's a lot of people around 2, and there's a lot of people around 8. So again, this is actually the mode. So I talked about the mode just now. So the mode is the most frequent, and we'll go over this in detail, so don't worry if you don't get it now. But we can see here that there's 2 things that stand out. The 2 stands out, and the 8 stands out. And so we can actually use both of these numbers. 8 and 2 describes the center of the data. In this case, they're modes. And if we have a distribution like this that looks like this, with 2 modes, we would call it bimodal, like bicycle, bimodal. So hopefully this little exercise just sort of confirms what is probably pretty straightforward, is that we have to kind of look at where the center of data is, and that's what the central tendency means. And actually, we've already talked about a very important principle that we'll go over later in the lecture, which is whatever you use for central tendency as the measure depends on what type of distribution you have. So here we could actually use the average. We call it the mean. Why? Because it's symmetrical. So if we just add all these things up and divide it by the number of scores, the average is the best measure of central tendency because it's symmetrical. Sorry about this. I have this laptop, and maybe you have this experience too. It's not the most expensive laptop, and so anytime I lean on the pad, sometimes it changes automatically the size of whatever I'm looking at, which is really annoying, but we can put up with it, I think. And then this one, we have a skewed distribution. And with the skewed distribution, we have some problems. We probably don't want to use the mode because if we use the mode, it's 8. The 8's not really fair because the 8 really is only taking into account these people over here. It kind of ignores all these other people. And the mean is not great because the mean gets pulled down this way because of the extreme scores. And so we want to use something that's the center of the data, which is called median. And again, we'll go over this in detail. This is actually the lecture that I'm giving you right now, median. So in a skewed distribution, we know that the mode's not fantastic because the mode is ignoring a lot of people. The mode is right here. That doesn't look like the center of data to me. And then the mean is not great. So the symbol for mean is this. I hope I put the little bar up here. Because we know averages get pulled towards extreme scores. So we have a few extreme scores here. So the mean gets pulled way over there. So we probably want something that's in the center. So the median, and I'll show that a little bit better. The median is the physical center. It's the 50% are above here, 50% below it. And then a distribution like this that's really kind of strange because we have two modes. There's kind of a dip. So it's not a nice flat curve. The mode is probably the best in a case like this because it's such a weird distribution. There's no scores in between here. So talking about the two modes is probably the best. And so that's one of the principles too of what we're going to talk about. A very important principle is which measure of central tendency you choose to summarize your sample's data depends a lot on the distribution of those data. So we just talked about this in a more straightforward manner. So we have 3 different measures of central tendency, and each of them are useful for different types of different distributions. It says distribution shape. So shapes, we mean normal curve. You could have a negative or positive skew, or we could have something weird like a bimodal one, which we just looked at in the lower right-hand side. So with statistics, we don't want to be unthinking. We want to make appropriate decisions that tell the person who's looking at our research what's going on. And so one of those things is central tendency and which of the 3 measures best represents what's going on with our samples data. Okay, so the first one is very simple. This is the average. So we already introduced the concept of mean. The mean is the average that you've been doing forever in your life. It's just that, why should we call it an average in statistics when we call it something else and confuse people? So the mean is the average that you're used to, the arithmetic average, which means you add all the scores together, divided by the number of scores to get the average. And so remember, to further confuse you in statistics, we have 2 different symbols for the same thing, whether we have a population or a sample. And so if we have a population, the mean is this little u thing, which we call mu. So if you see this, you know that's the average for a population. So if you know everybody's score in the population you're studying, you use that symbol. Or if you want to symbolize it in a formula, you use that symbol. If you're talking about a sample, so a smaller subset of your population, and usually you're studying a sample, you use this or use that X bar that I had before, the X with the little line on top of it. Either one is fine. They have this one because it's easier if you're doing typical typing in PowerPoint. It's easier to do this one than the X bar. Either one is fine with me. And both these formulas are the same. So both of the formulas are saying that you add. So this little sigma, they call this E thing a sigma, just says add all these things together that follow it. So here it just says the scores. So X is a score, every score that you have. Let's say that we have a test score in class. So everybody's score on the test is an X. So it's just saying add everybody's scores together. Sigma means sum it, add these things together, add the scores together. divided by what? Divided by the number of scores. So n is the number of scores, or number of data points, if you want to call it that. I think scores is a little bit easier to remember starting off. And again, we have separate symbols, but they're similar symbols in the sense that when we talk about a population, we use the capital N, and the sample we use a small n, although we'll get into some changes with this in formula later, but for our purposes now, capital N is the total number of people in your population. Small n is the number of people that you have in your sample. So what I'll say is in statistics, one of the things to do is not to get freaked out by the formula, because I know I've seen this in person in class. We're online right now, but in person in class, whenever a formula comes up, I see the look in people's eyes. It's like, oh my gosh, what is that? So part of the trick of statistics is to demystify the symbols and formulas. So this is actually just saying what you know already. You already know to get an average, you add the scores together and you divide it by number of scores. So this is just symbols saying that same thing. Sigma says add those scores, X's scores, divide it by the number of scores. So when we talk about formula as we go through the class, I will try to emphasize that. It's not to freak out when you see the formula, but to understand conceptually what it's saying. And because you know the conceptual stuff usually, it's just that the formula is a mathematical way of expressing it. And again, in statistics, we like to make things look really fancy and complicated so people think that we're really smart. So this is part of the ploy, I think. Okay, that's one measure. We've already talked about median also. So median is the middlemost point. So the median is literally where 50% of the scores are above it, 50% are below it. So it's the middle point. So if we listed everybody's scores from lowest on the left to highest on the right, the median is that midpoint where half are above it, half are below it. And in real life, you've probably seen median. Usually they use median for things like income or for like house prices. So if you are ever moving to another city and you're kind of curious what that city is, one of the statistics that is often given about cities, for example, they will say something like median income or median family income for that city. And then they'll talk about median housing price. So what does what's the housing price in terms of a median? Because they don't want to use averages, because some people has like, you know, $50 million homes, and that would just drive up the average, and that doesn't represent most people. The same thing for income. There might be a few people around that are just filthy rich, and the average would not represent really the samples or that city's real value in terms of the income. And so when there's extreme scores, when we have skewed data, we use the median as the value that for the central tendency. So when I said value earlier, I meant value as a specific number. And it's really easy to do the median. So this is exactly what I would suggest that you do, is that you put the scores in order from lower to higher, from left to right. And then you just physically find the middle one. And so if you have an odd number, your median will be an actual score. So an odd number, let's say there's an odd number here, we have 5 scores. The scores were 3, 5, 8, 10, and 11. And so to find the median, we just find the middle score. The middle score is 8. And again, with an odd number of people, the median will be an actual number in your data. If you have an even number, the even number may or may not be an actual score from your data. So here we have 6 people in our sample. And again, we put the scores from lower to higher, left to right. So the scores were 1, 1, 4, 5, 7, 9. And so here in this case, we know that our middle point will be between the third and fourth score. So it's good to sort of think about this physically. So if you think about this physically, I would count 1, 2, 1, 2. So then I know that these two are in the middle. So to find the, sorry about that. Again, this stupid laptop, if I press it in a certain way, it will just do things without pressing the keys. And so with this even number, we'll find those two middle scores. So there'll be two scores that are in the middle. And what we do is we average those two scores. So the two scores in the middle here are 4 and 5. You can see that there's two above, two below. So the median's actually here in between those two scores. So we just average them. So we take 4 and 5, we add them together, divided by 2. So the median is literally 4.5. That middle part right there. So 4.5 is not a score that anybody had in this sample, but it is the median because at 4.5 we have three scores. So 4.5, 1, 2, 3 scores below it, 4.5, 1, 2, 3 scores above it. So odd number, your median will be an actual score in your data. Even number, the median will be an average of the two middle scores, and it may or may not be a score from your data. It can be sometimes, but it doesn't have to be a score that's actually there. The key is it's the number that half are above and half are below. And so the mean is basically they call it the balancing point of the distribution. But the problem is that balancing point is really only relevant for normal distributions. And the mean is defined by distances. So basically, if you look at distances, the mean is where half of the scores are the same distance as the other half. I don't want to get too much into that because I think this is getting into a little minutia. So basically, the big point you should remember by this is it's defined by distances. The important thing with that is with skewed distributions that as we talked about before, those extreme scores, whether they're extreme low scores, a negative skew, or extreme high scores, a positive skew, those extreme scores, as you know, pull the average that direction. Why is that? Because the mean is influenced by distances. So if there's a lot of scores that are very distant from the other scores, it's going to pull the average towards that one. So it's defined by different distances. Median is just defined by the number of scores. So it's not the balancing point in terms of distances, but it's the balancing point that half the people are above, half the people are below. So both of these use the concept of middle. So middle distance is the mean, middle score of everybody is the median. The other measure of central tendency, mode, is not defined by middle. It's defined by the most frequent scores. And so here we just are showing that the median is only mildly influenced by extreme scores. So here's a very positive skewed distribution. So there's a 12 way over here, which is way higher than the next highest number that people got, which is 3. So the median gets pulled a little bit because, you know, this person counts. And so it kind of goes this direction, but it's 2.5. So 3 people are here, 1, 2, 3 people are here above it. However, the mean gets pulled way over. So you see the mean here is 4 because it's defined by distance. So there's one way over here, so we have to go this way a lot to make sure the distances are minimized in terms of the average. So extreme scores pull the mean towards them. So there's an extreme score here. It pulled the mean towards that 12. It's not pulled way over, but it pulls it to 4, which is quite extreme compared to 2.5 as a median. So that's one principle, is means are pulled towards extreme scores, and medians only just slightly. They still count as one person, but they don't count more than that. They count a lot more for the average because they're so far away from everybody else. So it tends to pull it towards that extreme score for the mean. So let's ask this question about mean and median. Can we calculate a mean and median with nominal data? Remember, nominal data are categories. Okay, so remember the mean is telling us to add the scores together and divide it by the number of scores. Can we add nominal data together? No, we can't, because there's not more or less even if we have numbers for categories, let's say 1 for psychology, 2 for sociology, 3 for physics, 4 for math, etc. We can't add those scores together. It doesn't make any sense. There's not more or less of a major. So we can't add, we can't do math, so we can't do mean. Can we do median? No, we can't. We can't do median because median relies on more or less. Remember, for median, we have to list the scores from lowest to highest, from left to right. So there has to be an order of more or less. And so we can't do mean or median for nominal data. So that makes it really easy, actually. So if you have nominal data, we're going to do the mode. The mode is the most frequent score. So we're going to use a mode when we have a weird distribution that's not like skewed or normal distribution, if you remember from where we started earlier. If it's skewed or normal, we're going to use the median or the mean. If we have something like bimodal where there's two peaks, but they're not really close to each other, in fact, they're not even connected in the example we saw, we're going to use the mode because the mean and median doesn't make any sense in that case. There's two separate peaks. Or when we have nominal data, we have categories, the only thing we can do is say what's the most popular major. We can't say median because we can't have major be more or less, and we can't do math, so we can't do the mean. So nominal data, categorical data, always mode is the best choice. Let's see here. And again, we can use this with any scale of measurement, but we really only use this when the mean or median is not appropriate for the distribution. And definitely use it all the time when we have nominal data, because we can't do mean or median. And we've already talked about that you can have more than one mode. In our opening example, we had two modes, we had two peaks. So in mode, there can be more than one score. For a mean and median, there cannot be more than one score. A mean median has only one score. Mode can have more than one. It can have one, like in a normal distribution, just has a mode that has one score. But modes can have more than one score. And that makes it unique among the three measures of central tendency. And here's another bimodal distribution. It's maybe not as extreme. And what I'll say is on this one, the temptation is to describe this mode, and this is the mode, it's 8. And the next highest is 7. However, if you were to ask me to give measures of central tendency, I would still call this bimodal. I'm not sure exactly how I'd word it, but I would say that the mode is 2. However, and I'd say mode is 2, and I'd list that the mode, the frequency is 8. Stupid thing. The frequency is 8. But I'd also say that 10 also has a frequency of 7, because I think if you leave out this one, it doesn't really describe the distribution. If you say the mode is 2, so the frequency is 8, the mode is 2, it makes it sound really weird. You would think that most of the scores are over here, but that's not true. So I'd say the mode is 2 with a frequency of 8, and then 10 has a frequency of 7. So you're sort of acknowledging that there's also something going on here. So you have a little bit of license in descriptive statistics, especially with the mode, how to do that. You don't have to just report the modes. You can actually report two things, even if one thing is just one lower than the mode, or even a few lower than the mode, depending on how many people are in your sample. The key in descriptive statistics is to describe what the stuff looks like to somebody. So I would probably call this bimodal. Okay, so this is just an illustration. We had one earlier about outliers and how outliers influences mean. Here's with real numbers, not just looking at scores, but if we want to calculate it, let's say we take a sample of 10 people in our class and we had them do push-ups. And, I'm guessing that we'll have quite a few people, especially after the COVID quarantines, who probably aren't going to be very good at push-ups. So we might have people doing 2, 3, 4, 5 push-ups, and then we may have some exercise guru who can do 50. So if we actually do the mean for these 10 people, the mean push-ups is 8.3. Is that a good description of the sample? Well, no, not really. Only one person got a score that was above 8.3. And then the next closest person was 5. That's quite far from 8.3. So you can see that number gets pulled towards that 50 person. And by the way, the median is 4, which I think is a pretty good measure of central tendency here. The mode is 3 and 4, so I'd say the mode's maybe not fantastic. I think median is good. And in general, again, when you have skewed data like this is positively skewed. Skewed data, we typically want to use the median. Okay, let's actually look at this question. And we're going to draw all 3, and we're not going to calculate them. We're just going to do this thing conceptually. So let me do this real quickly. And I want to think about how I want to do this. Maybe I'll do it side by side. And so I'm gonna sort of split this in half, and maybe I'll draw a little line here to remind me about my limits. So here's a normal distribution. Again, I can't do a perfect normal, but you know what I mean. It's roughly symmetrical and normal. So in a normal distribution, again, we want to use the mean. Why the mean? Because when it's symmetrical like that, and we have sort of equal distances as we're getting away from the center, the mean is the best. The mean is the most accurate. And so, assuming this is all symmetrical, the mean is actually right here in the middle. Because there's same amount of people on this side, same amount of people on this side, it's symmetrical. So the mean is right in the middle of the data. And actually also the median is right in the middle in a normal curve. The median is also here. Why? Because if it's symmetrical, 50% of the people are above it, 50% below it. And then the mode is also here. So the mode is also right here in the middle. Why? Because there's a peak. There's one peak in a normal distribution, and it's right in the middle. So in a normal distribution, the mean, median, and mode equal the same number. However, we use the mean. Why do we say the mean? Because the mean is the most accurate because of the distances. The mean takes all of the numbers into account mathematically. In a normal distribution, we won't have any bias in the mean by being pulled towards extremes because we have that symmetry. And basically, a good thing about this to remember is we often will not have perfect normal curves, so only perfect normal curves have this property that all 3 things will be equal. So given that, if we basically have something that looks roughly like a normal curve, you use the mean, it's the best. And then let's say we have a skew distribution. Think about how to draw the skew. Let's make it positive skew. So we have more scores kind of pulling off at the higher end. So let's just start off with the easiest one, which is the mode. So the mode is here. It's where the peak is. But again, is this a good measure of central tendency? Not really, because it just cares about the most popular people. So we're the most popular, and forget you guys over here. We don't care about you. We don't want that because we want to have the people in the extremes also be described in our central tendency. So the mode is not good with skewed distributions. The mean is also not that great because the mean will be pulled towards the extreme. So the mean is being pulled towards the extreme. So the mean will be maybe somewhere around here. This is just a rough guesstimate. So the mean is not great because it's pulled way over here, and there's a lot of people over here, so it's not really a great representation of our sample. So the median is the best, and the median is where 50% will be below, 50% above. And so the median will always be in the middle of the mode and the mean in a skewed distribution. And it's a good compromise, if you will. So the mode is not good because it ignores the people over here. The average, the mean, is not good because it pulls over way too much this way and basically ignores people over here. So it does the opposite thing. The median is good because it's fair. Everybody counts as one. So everybody counts as one. 50% are here. 50% are above it. So in a skewed distribution, the median is the best. And we'll see that in the next slide, but I wanted to draw it out because I think it's nice to draw out. So you see the same thing that I just talked about. So in a perfect normal curve, the mean, median, and mode are equal when it's perfectly symmetrical. But typically, we will not have a perfect normal curve. We'll have a lot of things that look roughly like a normal curve. So we want to use the mean. That is the most accurate measure that uses all of the data sort of equally. And if we're not worried about being pulled one way or another in roughly a normal curve, we use the mean, the average. When we have a skewed distribution, again, the mode just cares about the most people. So it's kind of a rotten measure of central tendency in a skewed distribution because it ignores the people at the extreme, and we shouldn't ignore them. And the mean is not good because the mean gets pulled too much towards the extreme. So it kind of ignores all the other people in the distribution. So we want something that counts everybody as one. Very egalitarian. So in a skewed distribution, we want the median. And again, the median is a nice compromise because it's in between the mode and the mean. Everybody counts as one, even the extreme people, but the extreme people don't count for any more than one. With an average, they kind of count more than one because they're so far, they're so distant from the other people. They actually overly influence, overly pull the mean towards them. So this just sort of summarizes things. So the mean is really good when we have basically a normal curve. We don't want a lot of extreme scores or skewed scores. And we can't do it with ordinal data or with nominal. Ordinal, sort of, but the truth is if you do ordinal with a mean, it doesn't mean anything because all they are ranks, so you don't really know exactly what that means. So nominal categorical data you can't do because you can't do the math. Those numbers are not numbers. Median, you want to use it with skewed distributions. It's not really good with a normal curve necessarily because it might be slightly off from the average. So normal curves, we want to use the mean. And we can't do the nominal scale because it's categorical and you don't have more or less. The median needs more or less in those numbers. Mode. You can only do mode with nominal data. So if you would have nominal data, there's one choice of what to do. It's a mode. And then a mode is good when you have something that's odd and doesn't look like it's a normal or a skewed distribution that might have bimodal or trimodal or more than one peak. And here's how we graph means or medians. In this case, it's a mean, but here we have continuous data on the bottom. On the horizontal scale, it says drug dose. Let's just assume that this means hundreds of milligrams. So 0 milligrams, which would be a placebo, 100 milligrams, 200, 300, 400 milligrams. So we have basically a ratio scale down there. And this is why we touch the lines, we connect the lines, because they are connected. They're ratio, scale, or even with the interval, we could do this. And then we have the outcome. So the outcome is mean food consumption. So maybe this is a diet pill. And so that I would not advocate. I don't know why you would take pills to help you diet, but people have. We have mean food consumption, which is the dependent variable, the outcome we're looking at. So we think the drug, which might be a predictor variable where we aren't manipulating anything, or it could be an independent variable where we are systematically manipulating the drug doses to see how it affects people. And the effect we're looking at is how it affects people's appetite. So how much food they eat. So you connect the lines with dots when you have ratio or interval scales on the horizontal, because they're connected. These numbers are connected. They're at least interval, but obviously ratio with a true zero here. So if we have nominal scale on the horizontal axis, here we have region of the US. So those regions are not ordinal. There's not more or less of a region, and not interval ratio, obviously. It's a nominal categorical scale on the horizontal. And then the thing that we're looking at is the median housing cost. So how much a house cost in terms of the median one for that region. And so given that we have a nominal scale on the horizontal axis, we don't want to connect points because they are not connected. They are just different categories. So when you have different categories, you do this histogram looking thing where the bars are not connecting. And that's it. So I mentioned that this would be a pretty easy and straightforward and short lecture, and I think it was pretty decent. So we will continue our descriptive statistics lecture with variability in the next lecture. So for this lecture, we're going to pair it with the next lecture, variability for the next homework and the next lab. So you cannot do the next homework and the next lab until you finish the variability lecture, and then there'll be homework and a lab for these two topics of central tendency and variability, which is the next lecture. So I will talk to you then.